Welcome to another Observable Lightning Talks. It's the September edition. So we had already, it's the fourth one, in fact, once per quarter. We could maybe increase the pace for this, but I think once per quarter is good enough for me at the moment. We can figure out if people like it to increase the pace. But again, I think once per quarter is fine. So if you don't never heard about Observable Lightning Talks, welcome to the Observable Lightning Talks. It's going to be about an hour, a bit more live stream with three different speakers. And today we have a pretty exciting lineup, to be honest. So keep you stay tuned. You will listen to a very insightful speaking track about different topics, about observability, about tracing in different aspects, or event-driven or tracing, or in the other side, it's more enterprise tracing, I would say. So that's really interesting if you have projects touching those technologies. So for those who is just connected, if you have time, just say hi and say where you're coming from. But otherwise, let me briefly explain the flow of today. So today, as usual, we will have three lightning talks. So 3 times 50 minutes with three speakers. And then we will end at the end with a panel discussion. So which means if you have any questions during any of the talks, we won't answer them lively during the 50 minutes talks. We will have a dedicated track for this at the end. So the last 50 minutes of this live stream to cover all the questions. I will take advantage of asking all my questions. And if the speakers has all the questions to other speakers, they will also ask questions. But also, if you have your own questions, don't be afraid. Just drop your questions. It's the panel discussion is there for that. So today we have an interesting lineup. We will have first. We'll start with Tamimi. So Tamimi, we recently did an episode on event-driven tracing observability using Solace, and Tamimi was interviewed during that session. So he's going to go deeper on that aspects about event-driven tracing, do a demo. So stay tuned. It will happen in a few seconds. Next one is speaker is Angelika Heinrich. So she is going to talk about enterprise-wide observability trends and blockers. So she is very specialized in mainframe, and has built an awesome product. So I'm very excited to hear more about that aspects from Angelika. And last, we have Bartek. So for those who never heard about Bartek, first of all, it means that you're not following what happens in CNCF. So Bartek is doing a lot of amazing stuff with a lot of popular projects. So Thanos is one of them. He is also contributing and maintaining Prometheus. So he's very involved in the open source world. So very excited to have Bartek today. And he's going to talk about the art of macro benchmarking using cloud native observability. So as a performance engineer, I'm very excited to learn more about all the secrets of macro benchmarking. So again, stay tuned. In a few minutes, you will cover all those aspects. So without waiting anymore, let's start with the first speaker, which is Tamimi. Hey, Tamimi, how are you?
Hey, Henrik. Thanks for having me on the show. I'm doing well. How you doing?
I'm very good. Pretty much busy. I mean, like everyone, it's the
Yeah,
conference season, I would say, where we have lots of things to
for
prepare.
sure.
so,
Yeah.
so it's another conference to deal with. But but very happy to have you on board and to share more insights about event-driven architecture.
Fantastic.
So, are you ready to rock on stage?
Yeah, I'm ready. I'm ready to talk today. So I'll just do a quick kind of verbal speak, and then I'll share my screen. I'll do like a quick demo within the 15 minutes allocated, and then we'll just take it from there.
All right. So I'll leave the stage for you. So see you in
Perfect.
15 minutes then.
Thanks, Henrik. All right. Thanks everyone for attending, and then Henrik, I'll let you know when I want to share my screen. So far, I'll just have my regular camera, and then I'll share my screen later. So pretty much today I'd like to talk about distributed tracing and event-driven architecture, which is a topic that is near and dear to my heart. So for those of you who are already in the field of observability and distributed tracing, you're already aware of the importance of having the distributed tracing in your overall system, in your overall architecture, and kind of the benefits of having a distributed tracing strategy when you do such solutions. So when you when we're working with event-driven architecture and there's kind of an element of a message broker and eventing is happening in your system, the importance of distributed tracing is also kind of as well viewed within an event-driven architecture system. So the event-driven architecture world or industry that is facing is not being able to track or trace the messages that are happening within the broker. So there are a variety of technologies that shows how like a message is coming inside a broker and leaving a broker, but it's also quite critical to get information on what happens within the broker. So questions like, was the message received to a particular queue? What happens when a message fails inside the message broker? What about dead message queues? Do I receive acknowledgements from the broker or from microservices? And to kind of highlight that, I will quickly kind of showcase a particular demo that I'd like to talk about. And in this demo, I'll be just scratching the surface to what can be done within distributed tracing in an event-driven architecture. So I'm going to go ahead and share my screen over here and kind of highlight a couple things that I would like to show. So first of all, as Henrik mentioned, we did host. We Henrik had a video on distributed tracing in event-driven architecture, and in this video, I talk particularly about distributed tracing in details in event-driven architecture, with kind of like showing a little bit diagrams on what to expect. But today in particular, I would like to highlight a couple things from a demo that the OpenTelemetry community has to provide. So, if for those of you who are aware, OpenTelemetry.io is kind of the main site for all things OpenTelemetry related. So, there's a community, blogs, different things for documentation perspective. But in particular, today I will be delving into what they have as the demo architecture. So this demo, particularly, I'm going to highlight the first one over here. It provides a realistic example of a distributed system that can be used to demonstrate open telemetry instrumentation and observability. So it is an e-commerce demo where there is kind of different microservices. It's a polyglot of languages. There are microservices with different programming languages that shows how every microservice is interacting with the others. So you'd see these microservices that are interacting with like HTTP between different microservices. What I will be focusing on today in particular is this section where we have a checkout service and there's an accounting service and a fraud detection service that's using a queuing system. So what I will be doing over here is basically have both a Kafka and a Solace broker in the system that showcases how we can do kind of distributed tracing and see distributed tracing within the overall system. And the nice thing about using OpenTelemetry collector in this example is we can choose a variety of different observability backends. So whether you're using any open source observability backend like Jaeger or any particular advanced observability tools like Dynatrace. And in this example, I will be using Dynatrace to configure my system. So let's go ahead and check out the demo. So you can check out more details about how to run this demo locally. I've configured this demo to include a Solus broker and to export to the traces to whatever we want. So I'm going to quickly show you what this demo. So when we run this demo, it is a very basic, simple e-commerce website. And in fact, I wouldn't say it's a basic, simple one because there is a lot of work that went into it. It's a sophisticated front end where you can go in there, go shopping, choose whatever product you want, you add it to a cart, and then you go ahead and you place the order. So this is kind of like showcasing how on the front end there is a workflow of different things that you can use in this particular demo. So what I've set up behind the scenes is I've set up both a Jaeger dashboard and a Dynatrace dashboard to showcase what's happening in the systems. So I'll delve in a little bit about Dynatrace and the Jaeger, and then we'll delve into a lot more details about how we can view the traces from a messaging component in the system. So from a data trace perspective, you can see I have my dashboard, and in the dashboard, I'm seeing all the different services that are happening. So this is, for example, the checkout service. There's the accounting service. There's other information around here. And all the different traces are seen in the services section. So I can go in here and see all the different services that I have in my system. So going back to the architecture, what I would like to see is all the different traces that are related to an accounting service or a fraud detection service. So let's say, for example, you are publishing messages from your checkout service on a particular topic, and you want to trace that particular topic and how it goes. Like what's the path that that message, the path that that message took inside my system. So let's go ahead and I'll start with Jaeger, and then we'll go ahead and delve into more advanced search options within Dynatrace. So let's say I'm searching for my accounting service, and I want to look for all the different traces. Do note, by the way, that what's happening in this particular demo, we have a load generator that publishes or that generates fake data into our system. So we have here our load generator. There's a bunch of load that is happening directly into the system. If you want to read more details about it, you can read on this demo. So what's happening over here is I'm going to go back to my Jaeger UI, choose one service in the accounting service. So I will use this. And I want to point out a particular kind of traces. So you see here, the checkout service has two separate traces. The first combination is done via Kafka, is what happens when the checkout service publishes messages to a Kafka topic, and then we have two different services that subscribes to it. And I've modified the accounting service to subscribe as well to a Solace broker on a particular topic, and the checkout service is publishing to a Solace topic as well to the Solace broker. So you can see here from an accounting service, we've received, we've gotten the span receive, and this is our Kafka related information. So you can see information about the Kafka topic in here, or the Kafka spans. And to get more details, over here, I would like to highlight how the Solace broker, or the Solace portion within the spans, has more Solace related details. So let's delve into this and kind of see what is related in this particular. So if I click on the accounting service, so this is the accounting service from an API level. From an API level, so it says kind of like, hey, I received a message, and then we can get more details about it. From a Solace related spans, I can go ahead and expand and see that I have an accounting order queue. So here the message came directly into my queuing, my accounting order queue. It was queued into it. And then we get more information about it. So in this, what I just highlighted is that from a Solace broker perspective, we've generated more detailed spans in what happens within the broker. So over here, we said that the message got queued into the Solace broker. There's even more information saying that the message was sent to the accounting service microservice, and the span was generated from the Solace broker. So in this particular example, we've or have highlighted how a particular spans are being generated from the broker within your system to get more information. So you might ask, how can we see this as well within a Dynatrace dashboard? So I'm going to go ahead in here and check out my services. Again, the advantages of using an advanced observability backend. So whether you're using Dynatrace or a Datadog or any other advanced observability backend, you have the opportunity to even fine grain the search within your generated spans inside your whole system. So imagine you even have a much more complicated system in here. So what I'm going to do is search for a particular service. I'm going to go ahead to my distributed traces over here. Service name, I'm going to go search for Solace as a service name. And what the Dynatrace dashboard is doing is filtering out all the traces that are related to my Solace related service. So you can see here, if I click on one particular distributed trace within my system, I can see the one message that was published on topic test that eventually was in queue to the Solus service, what is the path that it took? So I'm going to go ahead over here and zoom in a little bit. You can see that my checkout service into Solus, into the accounting service. So what I just showed previously inside my Jaeger dashboard, and I can delve into more details into what happens within the Solus broker, what happens in the spans that are generated from the Solus broker as well. So if I click into one of them, I'll zoom out. So now I can get more details saying, okay, this is the trace ID that came into my Solus broker. Here is the operation. It was a send operation. Protocol is SMF, which is a Solus message format, and the system, it came from a Solus PubSub Plus broker. And you can get obviously more information. Now, since I am not an expert in Dynatrace dashboard and any other observability dashboard, there's obviously so much other related details that you can do, or activities that you can do within a Dynatrace dashboard that you can leverage within your system. So this is kind of the active demo that I wanted to be part of this talk. Lastly, you might be asking kind of like, how is this happening? So this is kind of like a quick overview on what's happening in the system when a message goes in. So think of this microservice on the left-hand side is my checkout service, what I've shown earlier in my demo, and the subscriber on the right-hand side is my accounting service, or my fraud detection service, that is subscribing to a topic, particular topic published in my system. So what happens over here is the message is received in the event broker. The event broker will generate spans into a Solus related queue. And in the Open Telemetry Collector, I have a Solus receiver that is connected to my Solus broker and binding to my queue that has all these spans related to my system. So now here you can see that the context is being propagated. My checkout service is releasing trace messages. My accounting service is releasing trace messages. And my Solus broker is also generating Solus related trace messaging. And it's all going to the OpenTelemetry collector. And what I'm having over here is my observability backend. So in this case, I had Jaeger and Dynatrace set up to consume the traces that are being generated from the OpenTelemetry collector. And depending on the observability tool that I'm using, the observability backend, the tracing are being stitched and the context is being generated. So I'm going to go ahead here and show you how the context is being generated within, propagated within my overall system. So what I just showed you right now is how context is being propagated within the broker. The importance of having such a thing, such a availability, or such kind of support for generating traces within or within a event-driven architecture system is you can have data lineage, you can have more further analytics, detailed analytics, debugging, like figuring out, let's say that an issue happened within a my system. Did it happen within my message broker? Did it happen within my messaging system? And then obviously, like there's a lot more information that we can release with this. But what I wanted to show is kind of scratch the surface on a possibility of what happened within distributed tracing and event-driven architecture, and the extra information that is being released. Due to the time limit that we have in this lightning talk, I'm going to pause here and obviously show you that if you want any more further details, we are available in the Solus community that we talk regularly around distributed tracing and event-driven architecture and how we can provide such. So that's what I have for today. And Henrik, we can stop by sharing my screen. I believe I am within the 15-minute limit right now.
You did an amazing job, and there's a questions that just come up. So we will cover that at the panel discussion. So Rebecca, first of all, a pleasure to have you connected. Thanks for watching this content. So we will cover your questions. So be patient. We will answer to your talk. So thanks, Les, for your presentation. I also have some questions, but again, I keep them for the panel discussion. So without waiting anymore, I will suggest that we move to the next talk, which is Angelika. Hi, Angelika. How are you?
I'm good, thanks. How are you, Henrik?
Very good, very good. So first of all, I had the chance to be part of the Open Telemetry monthly discussions in MEA, and this is how I met Angelika. And
Yeah.
most of the session that we had on those monthly discussions were related to mainframe tracing, and I was very interested because mainframe I had the chance to work a bit on mainframe when I started my career, and then I never thought about, hey, let's move out to mainframe tracing. And I think you did a great job because I think a couple of years ago in 2018, you sort of worked on a first release of a product that will be like an APM product for mainframe providing traces on DB2. So the product was called Z Iris, if I'm not wrong.
Yes.
And now your mainstorm concept is basically the main software vendor behind the scene.
Yes.
So I'm very excited to hear more about that. So I'm not going to talk more. I will let you on stage for the next 15 minutes. So good luck.
Thank you. Thank you very much. So, yeah, as Henrik mentioned, we're going to talk about enterprise observability, some challenges and blockers. I wanted to make it a little bit more positive, so I said opportunities in this case. What we've observed while engaging with enterprise organizations who are exploring either at the beginning of their observability journey, so moving away from traditional monitoring practices and really trying to get those in-depth insights that we just saw. And also I want to talk about some opportunities, so ways to sort of overcome those blockers, those are taking advantage of those opportunities. A little bit about me. I'm a software project manager for Z Iris at Mainstore Concept. We're based in Germany, and we provide mainframe inclusive observability in third-party observability platforms. So what that means is we're generating telemetry from mainframe applications in open telemetry format, and we're then able to integrate the telemetry with any observability platform you work with. So just as an example, here we can see a Datadog service map, and we can see a couple mainframe services that are interacting with our upstream microservices. For example, we have ZOS Connect, which is a REST API gateway on ZOS. And this is then forwarding the API requests to downstream backend services, for example, Kix transactions or DB2 on ZOS. And Wola, which is a WebSphere open local adapter service on mainframe. So all of this is obviously provided through the spans and traces we generate. As you can see, it is already correlated. This is because we're doing the context propagation. And so users are able to really get that end-to-end view, seeing how transactions flow from your user applications all the way down into the mainframe. So that's what we're doing. And through my engagement with a few customers, I gathered a little bit of intel. And I think just before I start, I decided I would add a picture of mainframe because a lot of people are like, oh, I haven't seen a mainframe before. What does it look like? Why do people still use mainframe? So typically you'll see, your Fortune 500, I would say probably the top 50 banks will definitely be using a mainframe, especially those that have been around since 1960s, 1950s, so long-standing organizations. Mainframe at the time was a way to have enterprise computing business machines, right, IBM. And since then, it has just been growing and modernizing. And so this is a picture of a Z16. This is the latest model released in 2022. Everyone's in love with it because of the AI accelerator chip that is integrated in the Telum processor. And I've just included a little snippet of information about the type of processing power we can expect from these types of machines going forward. So very exciting stuff. A lot of customers are, I think, excited to try AI incorporated into the actual hardware that is hosting their core services. Okay, so let's talk a little bit about what we've observed through our customers and our users. So I've used this picture of an incomplete puzzle because I would say 95% of the customers I've worked with, this is pretty much what their observability looks like. There is some complete pictures, there's a lot of questions, there's a lot of parts they know exist but are not visible. So for example, the foreground here we can see is quite blurred out. So, fuzziness, fuzzy awareness of what's happening. The first thing I want to talk about is what I've at least seen is that the cloud and container applications are typically monitored separately to everything else. And this may be inherent to cloud container application technology being relatively new compared to a lot of the infrastructure that these enterprise organizations have had running for, decades, let's say. So cloud and container applications have more access or have the capabilities inherently there to have telemetry, so traces, metrics, logs, etc., generated, whereby things like mainframe, for example, this is not inherently there. This is something we have to buy from a vendor or build ourselves, which can be tedious. And so we typically see something like this, where we have backend services. This would include IBM Z, IBM I, AS400, so all your backend services. They have little, if any, observability. So what I've seen is the stock standard is metrics in dashboards, but tracing is probably, I think, about 5% of the customers I've worked with. So there is no real way to track how transactions are actually coming in from the cloud and the microservices outside the mainframe and being processed, and what the KPIs for those mainframe services are. And lastly, unmapped. So we have these two monitoring platforms, so one for your containers, others for your backend services, and no mapping. So what we see is customers talk about how when there's an incident and they know the IP call is going in the direction of mainframe, the mainframe team is just called up pretty much for every single incident that they might think has something to do with the mainframe. This means that those platform admins are inundated with having to respond to MIMs or any tickets. And typically you'll have that one guy, Joe, that's in every call, that knows everything about the mainframe and is somehow able to just quickly identify, no, I don't think it's, on our side, it might have been a new deployment change that happened on the container that has now, there's a conflict with the configuration, just for example. So this is what we see. It's a lot of frustration. This causes, I would say, a huge gap and miscommunication between the upstream applications and your backend services. So very frustrating way of working. The second is, and I think it probably would be obvious for a lot of people on this stream, but in case it's not, there is a huge correlation to how observable your IT landscape is and how much you value observability. And I say this because I've seen, two types of customers. You'll have one very advanced in observability. A lot of their upstream, middleware, all of that is quite well observable. I mean, the observability is there. We have the traces, we have metrics, logging is correlated. And then there'll be a few black sheep that, sort of need to get updated and get that telemetry out there. And they see the value in getting those black sheeps to be observable. They see the value in having traces and metrics and correlations. And so it's a lot easier to quickly talk about what do they need, what is their goal, and how can we help them achieve it. Where other customers I've seen who maybe have one edge use case, or maybe they have a new business unit completely built in cloud, uses traces, has full observability. Rest of the organization is quite disparate. So using different types of tools, different types of BUs have different monitoring practices, they don't see a lot of value. It's a lot more talking, a lot more education. And so I definitely see a huge correlation in this. And why I want to talk about it is because if you're thinking about starting a project on enterprise observability, it's probably a good idea to figure out where you are on the scale as an organization. And this is the first opportunity I will talk about. Because when you know where you are, you know where you want to get to. And it makes the conversation, I think, a little bit easier when you're starting to roll out a new observability project. Let's be honest, at the scale of an enterprise, rolling out true observability can be difficult. Not every application running in the enterprise is on a container. There are a lot of legacy stuff running out there. We've got to do a lot of manual work, a lot of thinking. And so we see customers who've just come out of like a 5-year project to get their observability running. And now someone's come along and said, hey, I don't like product 1. I want to go to product 2. And everyone just throws their hands up in the air like, no ways, guy, I'm not going to do this again. This took forever. So really understanding where you are and where you want to get to in this scale is going to be a great step to figuring out how you're going to get everybody to buy in to your new strategy. And I would say the next logical step, but so one that a lot of people don't tend to have when I speak to them in the beginning, what is your goal? If you're only looking to reduce cost, often there are ways to already discuss this with your current providers. But if you're trying to close a gap that your observability provider cannot do for you. So for example, you want to use open telemetry, you want to integrate that into your existing platforms, you want to try and close gaps across the architecture. What is that going to bring you? Where are you seeing pain that isn't solved by the tools you have in place today? Be very clear about the differences between monitoring and observability. I often speak to teams, doing a demo, and they're like, "Oh, well, we have dashboards, and and we can see. So the guys can just give us a call and ask us what's the problem." And I tell them, "But that's the problem. Having to call you to understand why their services are slow is not observability. They should have access to that information or that telemetry in their tooling." So they don't have to call you, and they can make an educated or a qualified decision. Should I be calling mainframe teams for this? Or is this more obviously a problem outside the mainframe, for example? Which signals are important? And correlation. We know this on the stream, but don't take it for granted that everyone in your organization understands this, understands context propagation, traces and metrics being correlated and not simply just a dashboard, but really being able to go from a dashboard to a trace or a few traces of interest is a huge step forward or further than just monitoring. And last but not least, and I hope I'm still within my time, I have witnessed that customers or organizations with an enterprise-wide strategy on observability. So I'm not talking about specific products that you will use, but the framework and the mechanisms that you want to employ to ensure that everyone has the information available that they need to know about an application and enforcing it. So don't just have a strategy, you need to have a way to enforce this. Again, very clear reasons about why we're doing this and what do we want to improve with the project. Business is as responsible for this as you are, as IT, right? We need business buy-in for the money, and IT needs to have buy-in to engage and to actually deploy the agents or whatever technology we need to get that observability out there. And the last 2 points, have an advisory board or a council that is integrated into your architecture board, your change approval board, that is always asking the question, how are we going to monitor this? Where are we going to monitor this? And make sure that everyone, especially your friendly fellows on mainframe or in any other legacy infrastructure, understand it is not a finger-pointing game. It is a way to save us time and frustration and have clear communication between the different types of teams we have working in our organization. Right? We just want to be better. We want to be faster. We want to be stable. That's the goal. And that's it from me. Thank you.
You did an amazing job because it's again less than 15 minutes, so you did it. I have already noted some questions, so I'm not going to ask it right away. So first of all, thanks, Angelika. It was very clear, and I will keep my questions for the panel discussion. So see you in a few minutes,
Okay.
and let's introduce the next speaker, which is Bartek. Hey Bartek, how are you?
Hello, hello. I'm good. How are you?
Very good, very good. So where are you connected from? From London?
Yeah, London Google Office. It's I made some custom kind of desk that I can put my laptop on, and everybody is laughing at me, but it works. I have a nice kind of background, so I'm ready to go.
So for those who never heard about Bartek, so Bartek is one of the it's the technical lead, in fact, of Tag Observability. He's been working now. He's currently working as Google, as you may have understood. But previously, he was working for Red Hat. So he's been doing a lot of amazing engineering work during his entire career. And by the way, he has a book. So he's the author of Efficient Go. So if you want to learn more about Go, we'll definitely recommend to look at Bartek's book. But he is very involved in various observability projects, like I mentioned before, Thanos, Prometheus, and others. And I'm very excited that the title of the talks and the abstract that when he shared it, because I heard benchmarking and I said, oh, interesting. So is it going to talk about testing in production with Observability? Is it going to looking at Observability for performance engineer? So I'm very excited and already have questions without seeing a presentation. So I'm not going to reveal anything. So I will leave you talk for the next 50 minutes, and then we can cover all my questions and probably the question of the attendees. So good luck and see you in 50 minutes then.
Sounds good. Okay. Yeah. So we have two talks that were kind of like very focused on observability, but today I wanted to kind of like put my talk in a different angle a little bit. So I would love to showcase where observability is very, very useful, where maybe it was not used before very often, especially when you think about cloud-native observability tools like metrics, traces, profiles, and logs, right? So I want to kind of compose those two areas, which both are my passion, right? Like benchmarking and performance and kind of high efficiency software, as well as observability. So let's go. And Henrik already introduced me, but roughly speaking, I work at Google Cloud specifically. I'm responsible for Google Managed Prometheus service, which is kind of Prometheus compatible service that we offer in the cloud. But I also maintain Prometheus directly, so kind of like I'm in the split of these two worlds, managed service as well as open source, and it gives kind of a good opportunity to help in both areas. I'm passionate about open source. I maintain other projects as well, mostly in Golang, and I'm active in the CNCF. And as Henrik mentioned, I also wrote a book, Efficient Go with Rayleigh, and some of the content is from my book. So you're welcome to dive more into those concepts in the book as well. So let's go. And we only have 15 minutes, so I don't want to bore you with too much details on why we even optimize our software. But I want to mention one thing, or like two things. So maybe you watched recently the Apple event. It was like a week ago. And maybe you noticed that every third slide or every third kind of like, let's say minute, there was performance word. Every time they introduced some product or a new version of the product, they mentioned about performance capabilities and efficiency and how much, what CPU it has and what kind of processors it has. And this is not a surprise for many, I guess, because there are many reasons, right? Like, your product has to be fast, has to be kind of like cheap to to make sense for the business model. It has to be resilient, right? So it cannot like panic with out of memory and times out. So like focusing on performance from marketing level as Apple is doing, and also on our software is really, really important. And I could kind of give you many other reasons, but I mean, it's super, super important generally. And one excuse that we often use to postpone optimizations, we postpone work to make our software faster, is that hardware is getting better, right? Like, sure, we have more load, we scale our products, but generally our microservices can run on more modern hardware that is faster, and we have more cores, and we have dedicated hardware. For example, like on the Apple event, we learned that there is this new A70 Pro chip, and that's in fact not really true. Like, hardware is not getting better that much. For example, like random memory access speed and kind of single CPU core speed is really the same. It's not getting much better. Like, there are lots of optimizations on top of it, and especially we have just more cores available. But generally, the clock frequency is the same. So we are hitting limits, and there are reasons for that, right? There are kind of heating limitations why we cannot faster clocks and so on. And what really caught my eye during the Apple event is they then mentioned that their hardware chips are 12 silicon atom wide. So like, just without like maybe even expertise, you can kind of like imagine how much more atoms we can have to kind of like make those chips smaller, right? Which not that many, right? So this means that we won't be able to feed more and more transistors within one CPU, within one chip, right? So we won't be able to even kind of like put more CPUs or put more dedicated kind of processors for better hardware into our smartphones and kind of like PCs and so on. So there will be even more physical limits in the future, right? So hopefully we agree that we have to improve efficiency of our software, or we at least want to make sure that it's good enough. So this is where there are lots of processes. I defined a TFBO process in my book. It's called, well, it's kind of like acronym for test, fix, benchmark, optimize. It's kind of like gives you the direction what to do during development process to not forget about maybe some efficiency aspects. For example, when you create a software, you start from the left. You test it, of course. Like, would you test before kind of like thinking about efficiency? Once it's kind of working, only then you think about potential optimizations. But before even thinking about optimizations, you need to be aware about what kind of efficiency level we have right now. And this can be, this has to be obtained through benchmarking or assessment of efficiency of your software. Is it how much memory it's using, how fast it is on certain situations, and so on. And only once you know those numbers, you can make decision if you should optimize. Is it worth to optimize more, or maybe it's good enough to release, right? And when you optimize, then you maybe use those details that you obtain from benchmark to find bottlenecks, or you perform another experiments to find bottlenecks, and then you optimize. So I want to focus on this particular part, which is benchmarking and assessment, which is probably one of the most difficult part in the whole process, and it involves observability, of course. And of course, we can do benchmarking or assessment of efficiency of our software in theory, right? We could just analyze statically our code, our algorithms, our data structures, and kind of like gather some complexity numbers. However, in certain environments, like, it would be super nice to know the absolute numbers, or kind of like compare a new software version to old software version, and be able to tell if it's faster or better or worse from efficiency standpoint. So for those purposes, we often refer to benchmarks. So empirical evidence, kind of like experiments that give you empirical evidences on how your software behaves on certain environments. So let's dive into those. And essentially, we have three rough categories that I like to kind of split benchmarks into. So micro benchmarks, macro benchmarks, and production benchmarks. And all of them are useful in a certain scope. So roughly speaking, micro benchmarks is when you kind of like perform an experiment and try to benchmark a single function in your maybe one microservice, one kind of like, let's say, Golang service, right? And for this, for example, for Golang, there are native tools to do that. And It's kind of fairly straightforward. There is like a very quick feedback loop for this work. And once you do this benchmark, you have some rough numbers, right? You have some, kind of observability, right? You have maybe logs that were kind of printed. You have operations how much time it took per operation. You can do multiple of those to ensure reliability. So you know if the times are kind of the time results are very far away, which indicates that maybe your environment is unstable and so on. You have lots of numbers just for this one function, right? So that's great. But for complex services, you would need to do a lot of those to have some kind of like awareness of your efficiency for your whole complex microservice. So we need something better. And this is where we could try production benchmarking, right? So this is where you just deploy your service to production and see how it goes, right? Like your user starts to use it as they use the older version, and you see if they improve, if they kind of like, maybe you use more memory or less memory, maybe, kind of use more network, less network, maybe latency kind of varies. It's, of course, very dangerous, right? Like, because if you mess up, if your service is suddenly using more memory, unexpectedly more, then you have to mitigate those. But there are ways to mitigate that, and that's not bad, really, way of assessing your software. But maybe, and of course, here we are using observability tools that you often use for production. So let's say metrics, logs, traces, and continuous profiling. Let's see if there is anything better we can do here. So this is where macro benchmarks are pretty useful, because they allow small or large scale benchmarks in a kind of like fake mimicked production environments, right? And you can kind of benchmark multiple applications and deploy them and perform some experiments, right? They require additional work. They require additional compute power. You have to fake some kind of load generation that kind of mimics the user traffic, perhaps, for the things that you want to benchmark for. You have to mock dependencies. So it is not easy, but it is very kind of powerful. And in fact, what I want to show you is that you can, and you should probably reuse the same observability tools between what you use in production and here for many reasons. And one reason is that you want to kind of like make sure your observability also is kind of benchmarked within this production, right? Because what you gather, maybe you gather metrics, maybe you send logs, traces, whatever, like they also have some overhead. So you want to kind of like make sure you benchmark in as similar as possible configuration. So your observability should be similar as well. And you can totally use the same observability tools to obtain a meaningful benchmark results that you can analyze later, right? And I will show you how. So generally in my book, I kind of outline that as those three categories. And I kind of compare that to the testing, right? So micro benchmarking is really like unit testing. Just testing is for functional testing, and benchmarking is for performance testing, right? Then you have micro benchmarking. So it's kind of like integration test, end-to-end test, and then finally production on benchmark is like testing on production. Maybe not recommended, but in some cases, it's the best way you know for sure that something is wrong or not. So the rest of the time, I would love to focus on how to make macro benchmark useful with observability. So for this purpose, I want to introduce you like a framework that we use in Prometheus. So I maintain Prometheus project, and it's kind of funny because it's a project for gathering metrics for monitoring, and we also use it to benchmark, right? So, but we have to benchmark the Prometheus itself, like how we know if our monitoring is fast enough, if we can ingest the metric samples, if we can process them, and so on and so on. So we want to automate this, and we created this project called PromBench. And how it works is essentially you on a pull request, you have a new change, you say PromBench, please start, and then it starts with some kind of links to certain observability points, for example, to dashboards with metrics, which is pre-built with what you should look at when you are doing benchmarks. You have continuous profiling, so it gives you exactly that. It makes pprof profiles every like 15 seconds or so to know exactly the profile, so kind of like where that the most CPU cycles are used, or where the most allocations are happening within your code with an exact stack frame, with an exact function name. So it's super powerful doing benchmarks, and we should use it on production, in my opinion, as well. I love continuous profiling. And finally, maybe within this PR, we could decide what to do next, right? Based on those results, we could say, okay, sounds like memory is suspiciously higher. Let's kind of unpack with profiles or other signals, like what we can do about that. And maybe it's worth to merge it still, maybe it's not, right? And for any feature, for any optimization that might impact performance, we run Prombench directly in GitHub. So it's pretty useful. And I want to share this framework with you. It's open source. You can check it out, be inspired as well. So honestly, we don't have much time. So I will probably move straight to observability. But just to roughly mention, I really want you to know that benchmark, macro benchmark especially, has to be reliable, right? And what it means is the environment has to be stable. Like you have to be able to repeat the same benchmark, and the results should be roughly the same. And what's important here is that we do that by comparing two Prometheus versions, right? So we deploy application we want to benchmark, and we want to deploy reference application that is our reference, right? So instead of trying to find out absolute numbers, we care about the difference between memory usage of old Prometheus and new Prometheus, and we make decisions based on that. This is much more reliable than trying to, we measured memory usage from a year ago for this version. Let's see, now the new version has this memory usage. Okay, we can compare. Not really, because even Kubernetes version, then the operating system version changed over a year. You cannot compare those things. There are so many aspects that changes. So trying to compare within very quick time across two things makes more sense. We isolate in virtual machines, not in containers. We use Google Cloud and GKE specifically, and Kubernetes to do so. Here you can see we have certain node pools for experiment, for load generation, for even for the observability. There's the main node, whatever. It's one node where all the kind of meta automation stuff is placed, and it's totally different virtual machine. Finally, relevance. You have to make sure that your micro benchmarks are relevant, right? So this is where, for example, you could use K6 framework to simulate real queries. What you could do, and what we do, for example, is to also simulate dependency, right? So for example, we simulate the web server kind of generating some metrics, and we scrape them. It's not fake load. We try to simulate some kind of real web servers, for example. So our metrics that we consume by benchmark Prometheus make sense. And finally, observability. So what we do here. So we mimic what we would do in production, right? So we have Prometheus. So our Prometheus that is benchmark and reference is monitored by another Prometheus, which is kind of sometimes hard to kind of understand. But there are the separate instances, so they're kind of isolated, and it's pretty powerful that we can dogfood our stuff. And of course, we have some exporters like kubestate metrics, node exporters. We have Grafana for dashboards. And essentially, this Prometheus, we call it Meta Prometheus, monitors all the other services, including CI/CD, simulated web servers, and our load generator. And then we have those dashboards, right? So we kind of iterate over them, make sure we add performance metrics like memory, network, storage, CPU, and so on. Then we have logs. Honestly, I personally don't use logs during those benchmarks in the Prombench that much often, but maybe for some debugging cases it's useful. We use Loki and Promtail for that. Finally, one of the most useful things for me personally is Parka, which is a project for continuous profiling. All of those projects are open source, by the way, and essentially it gives you those continuous profiles I mentioned before. It's super simple to add. It just works very well with Golang applications for sure. It just scrapes the profiles out of them with minimal overhead. And that's really it for today. Maybe some lessons. Follow the test, fix, benchmark, optimize process. Make sure to look at macro benchmarks. Maybe they fit your use case. And I gave you some links to useful open source tools. And again, get inspired by this framework. by observability tools it's using, and so on. For example, at Google, we just fork this and kind of like maintain also normal prom bench and our fork, which uses like Google Cloud Services instead for meta monitoring for those observability tools, because we can host this there, right? So you can mix and match, you can play with it, and I recommend to try it out. Thank you.
All right. Thanks, Bartek. Very interesting. And I already have lots of questions, in fact, about the prom bench and what it does and how you size the bench and so on. So let's jump into panel discussion so we can cover all the questions that we may have. So see you in a few seconds. All right, so I have Tamimi who has an issue with first of all, thanks for the 3 talks. It was really interesting. Covered different aspects of observability, and the benchmark was really interesting portion of that. I wanted to start with Tamimi, but it seems that he has an issue. So let's go directly with Angelika. Angelika, you covered something that I thought it was very important to remind is evaluate the maturity of how you are in terms of observability, and then to identify the goals and so on. So do you have a specific methods to understand how mature you are, and do you get valuable signals that you can basically use in a comprehensive way through the current observability stack that has been enabled or deployed? So what is your process and methods for that?
Right. Yeah, good, very good question. I normally when I'm talking to a user or a customer, I have to take into consideration what I already believe their current situation is. Typically, what I see most success in is when an organization really digs deep into site reliability engineering, and having someone at that level to sort of take on this task at a sort of an enterprise scope. Too often we rely on 1 or 2 business units to sort of spark this process, and they don't have the scope and often the experience and the understanding of which signals are available, what value will they bring compared to what we have, etc. So really having someone with that ability, probably within your organization, a lot of platform engineers who could probably take on the role as an SRE. I see a lot more advancement with the SREs. Even enterprise architects have really, really good success in analyzing and understanding the scope of the organization. So having someone with that experience and with that knowledge is a good start.
Yeah, also you mentioned something about the difference with monitoring and observability is to have access to the actual data. So do you also somehow evaluate that most of the team involved in the project or in this environment has access to the data, or is it something that one point that you also try to answer, or question that you try to answer?
I do. I always ask who is going to want to see this data in the end. And why I always ask this question is because a mainframe team, we have specialized tooling on mainframe that provides us a lot of performance information, but this data is siloed. It's not something we can share with our development teams. And so I try to highlight with the mainframers, yes, you have great tools, but how are we going to share this info? Do you send an email? Would you rather not have to send an email? Would you rather that they're able to see it on their own without calling you? So yeah, I'm very specific about who are the users and understanding their pains. Typically, I see development teams struggling every day to understand where mainframe might be a problem, or is my application the issue? Did I deploy a change yesterday? The configuration's different. It's affecting our communication. And so they want more info to be able to do a qualified analysis of what's happening right now, so they know who to get on board at the beginning. It's that classic, 80% of the time we're usually trying to just figure out where the problem is. and 20% is developing a solution. We want to flip that. We want to be 20% figuring out where the problem is and spending most of your time providing a solution.
And just for the mainframe aspects, are you at the moment? There are a lot of automated instrumentation available through OpenTelemetry. I may do first of all, is those framework valuable and useful in mainframe, or do we have to go through the manual instrumentation path to get traces from, I don't know, let's say I have a COBOL program running here. I guess I want to have traces out of that. So do I need to also implement traces in the COBOL part, or what is the journey?
Yeah, so there are various journeys. There are very few application use cases on mainframe, I would say traditional use cases that profit right now from OpenTelemetry. Obviously, your Java workloads, you attach the agent to the JVM, you'll get your traces. But when we talk about COBOL, Assembler, PL1, these guys don't currently have the APIs available or the SDKs or anything like that. So we're seeing customers ask us, how can we build that into the code? So we're working with some users to try to figure out the best way to step forward on that. So is this something we can provide to attach to a program and we'll auto instrument, or start really building our own type of SDK for those various languages? Today, what we typically see is we won't have tracing built into the code, but we will have sort of a process that is listening in and catching those instructions and providing some sort of a trace or a metric, either or both, and transmitting that out. From a ZR's perspective, we leverage mainframe's internal managed repository, if I could call it that. A lot of applications are recording their performance in the mainframe, and what we're doing is extracting and transforming that data into real-time telemetry so that we can get more insight as the applications run. So a very sort of a non-invasive way to get the observability.
I think Bartek, you have the questions.
Yeah, totally. So super excited topic, by the way. It's not, covered enough, for example, on KubeCons, the mainframe use case. But I wonder, what do you think are the differences between, cloud native, let's say, environment and observability there and the mainframe? Like, what is the main different thing that we have to think about in terms of observability? We covered different languages and frameworks, for sure. But is there anything else, like maybe different service discovery, that is totally weird because Kubernetes is not there? There might be some other solutions. Is there anything that is that you have to totally change or a little bit change in the cloud native observability to fit into mainframe?
Right. So the architecture of C, right, so it is different to, I think, what we could call the typical AMD 64 infrastructure. So already there we have to consider where we are in the environment. It's very difficult to just take an agent and just, change up the code and hope that it's going to work. So the architecture in itself at a base level for those languages and the operating systems is a bit of a blocker. But I would say that the biggest blocker is that mainframe operating system technology and a lot of the applications running are owned, they're proprietary. So the only person we really can turn to is the creator to provide something to help us extract that, right? It's not like our wonderful world of Linux or a lot of other open source communities where we're all sort of working together to try and improve this. So I would say, please think about, if you're providing operating systems and applications to customers as a proprietary solution, build observability into it and make it available.
Thank you.
Yeah.
That makes sense so much.
Yeah, I agree. And also, one thing, because I remember when I was working with the mainframe, there was, the main platform owner or the main person managing is following how much resources have been consumed by each program, because you share resources and so on. Is this notion of how much CPU, or I don't remember, MIBs or something, I don't remember the name, has been consumed, so then you can keep track. Is this going to be available as an open telemetry metrics, and then you will be able to split by workload or processes and say, oh, this team is consuming most of the power of our mainframe, and be able to basically reach out and say, hey, you should try to figure out, optimize a bit the system?
Yes, that is always question number one. How much CPU is it using? Because just like on cloud, it's money. every single second on that clock costs you something. So yeah, that is number one. Can we get it at a per request level at a transaction? And can we also just monitor the overall floor of our CPU usage? Yes, and try to predict the costs and also find the business unit responsible for this. Yeah.
And then it reminds me that yesterday there was at the Tag Observability, there was Open Cost presenting the project. So it's really great that Open Cost is also sort of keeping track on the actual costs of in the mainframe. So that will be also an interesting angle to cover for sure.
Yeah,
Right.
for sure. Definitely.
So Tamimi, yeah, we just you had a network problem. So thanks to connect back. So I had a few questions on your talk. So first, you made that the demo. Do you have a GitHub repo that you can share where people can say, hey, I want to use the Open Telemetry demo forked with the Solace broker? How can I take advantage of that?
So we will have a public repo forked off of the official OpenTelemetry demo soon. I did include a couple things from our API that is under development, local development. So once we have this published, I will make the repo public. And I could share it with you as well, Henrik. So for those who are following you and wanted more details about that demo, we can definitely have it shared. But for now, I don't have anything public for it.
Okay, so I have a question. So I have the answer, but I still display it.
Mhm.
So it's Rebecca who said, "Do I have this correct? In order to see more details, traces pertaining to the Kafka messaging system, do I need to install another service on top of Kafka, the Solace broker, or the Solace broker replace Kafka?" So could you maybe explain, be a bit more clear, because I think a few things has not been fully understood.
Right. Great question. Then I do receive this kind of questions quite often. So the Solace broker is another message broker. So it will replace Kafka from a messaging system. However, if we've seen like so many different use cases where people have used Kafka for analytics related use cases and Solace broker for operational use cases. But do keep in mind that for a messaging system, whether it's Kafka, whether it's Solace, whether it's any other event broker, for the messaging system to generate spans, the broker itself has to support the span generation and the context propagation within the messages. So the Kafka broker, as a broker by itself, doesn't support the generating of spans within the broker. So think of span generation as three different layers. There is the application layer, there's the API layer, and there's the broker layer. If you're using Kafka in your system, the applications, the microservices can generate spans. The API that you use to communicate with Kafka can generate spans, but the Kafka broker itself cannot generate spans on if there's any queuing that happens within the Kafka broker or any messages lost or anything within the broker itself. Spans are not being generated. However, the Solace broker natively now supports the generation of spans. Let's say that you got a message that is enqueued on a queue. If a message was failed or when it went to a dead message queue, a span will be generated. Like any other information that is related to the broker as a system is being generated directly from the Solace broker. So Solace broker does not sit on top of the Kafka broker, to answer your question. And to my knowledge, there is no external support that extends the Kafka broker and generates the spans to it. So that's kind of like a fundamental concept that we need to kind of understand before delving into messaging in general, messaging and distributed tracing. So I hope this answers your questions.
Yeah, and then also I would just mention that you're just not a simple broker. You're a messaging mesh, which means if you get a Kafka message, then this message will be forwarded to another broker sitting in Google or in Amazon, and then you have like a flow of messages that goes to the right destination where there will be a consumer.
Right.
You having traces on this actual flow will be very useful, because if some reason your message has been stuck somewhere and you don't know where it's been stuck, I think the traces will provide the right answer.
Totally, yeah. And you bring up a very good point, Henrik, on this is now when you start extending your enterprise application to even a more sophisticated infrastructure where, in Solace, we support something called an event mesh, which is a network of interconnected brokers. Let's say that you have brokers that are geographically located across the world and you're sending messages between different different event brokers, having the ability to generate spans in an event mesh. So kind of we're having a distributed tracing enabled event mesh. You could trace where the messages are going between different hops in your system. So you can see how this could even have a bigger value once you have an event mesh in place, for sure.
Okay, great.
Yeah. Yeah.
So I think you covered most of the question I had. Bartek or Angelika, do you have any questions for Tamimi? Nope. All right. So Bartek, I have some questions because I spent 15 years of my career doing benchmarking and performance engineering and tuning and stuff like this. So first of all, PromBench. I was wondering. So PromBench, you're generating the data sets randomly, or do you test, for example, different type of use cases where I have a standard sets of exporters producing metrics where Prometheus is going to scrap that, or suddenly I have a weird exporter that has, I don't know, 50 plus labels exposed, and then you measure, okay, if I have a traditional metrics and then suddenly I have something weird coming in, what will be the impact for Prometheus? What is the actual strategy when you do the benchmark in Prometheus? Do you cover those various scenarios, or do you cover a typical, of say, average scenario that Prometheus is dealing with?
Yeah, good question. So it's when you're testing functionally something, right? Like you aim for the edge cases, right? You aim for something crazy like negative numbers or something like, large numbers. In benchmarking, because benchmarking is usually expensive, right? You want to, kind of like make sure you focus on what matters the most. You kind of do opposite. You kind of like try to normalize the case. You want to reduce cost for the most typical deployments to affect essentially, like positively the largest number of users. So what we aim for is like a standard load. It's higher than usual because I don't know if you saw, but in the screenshot there was like, we have like a 60 gigs virtual machines, and we aim for Prometheus using 30 gigs of memory. That's already millions of series. So it's kind of one of the larger load, but generally we try to have a typical load, typical node exporter, typical exporters, right? So we aim for that. However, there were cases where perhaps you are testing some kind of scalability issue. Then for sure, we see manual interaction into PromBench or manual tests because PromBench is made for automation, fully automated. So it's meant to kind of like repeated benchmarks. So maybe it's faster to just create some quick benchmark on your own. But to be honest, it's very easy to change benchmark for one run and deploy a little bit different scenario, right? So we also query Prometheus, right? It's not only ingestion, but also querying that can be an overhead. So we also perform some standard queries, and this is where we need more work. So if you want to contribute to open source, let me know, because we need to kind of have essentially provide some more queries and test different query scenario, large query, small query. And right now we have like very basic system. So yeah, you essentially try to do as much as possible with limited resources and gain some visibility, some observability into your performance.
So you're simulating the sort of how the Grafana client that sends PromQLs, and then you also have the scrapping aspect as well.
Correct.
And what is the? I guess you how did you manage to do the benchmark? You looking at, okay, so in your normal condition we have, I don't know, 10,000 counters. Here we have 100 histograms. Here I have. So do you create a representative assets? Testing data with different type of metrics that you will be pushed, or you do individual tests. So first I test the counter, and then I test the histograms, and then I test it. So what's the approach?
Yeah, it's all in, right? Like similar to the real scenarios, you would have a mix of those, right? So it's just arbitrarily chosen mix, right? And if we see certain problems, like for example, hey, maybe especially histograms are expensive, we kind of like adjust and iterate over this data and ask our fake generated simulation, web servers to put more of histograms to a little bit test it more, right? But hopefully with native histograms, it's solved, and like it's definitely histograms are much cheaper, and we can prove that within our benchmark as well. So It's not perfect, and within your production, maybe you want to have higher quality of those and do multiple scenarios, as you said. But we aim for usability. It's open source project. It's paid and sponsored by CNCF fully. I wanted to mention it, but we are capped at $1,000 per month on Google Cloud, so it's whatever we can do within this limit.
Okay, cool. And also, I really like the fact that what you mentioned, saying, because we used to do, like you mentioned, I'm doing testing version 2, and I'm going to look at the numbers that we had maybe 1 month or 6 months previously on the version 1, and then we compare from over time. I think it makes sense, especially in, like you mentioned, the operating systems is changing, community is changing. Having both of the versions sitting and then being able to basically compare live. You can compare lively if version 1 and version 2 is behaving
Correct.
differently. So I think it's the right approach.
Yeah, we run at the same time for different virtual machines. And maybe one note, like there was a cool discussion on Twitter, like if we would have like a mainframe, maybe not, but like small PC that you never touch, you never update anything, you just run this process, you could compare, but like you would need to have exactly the same temperature in the room, the same humidity. Is just unrealistic. That's why you have to do comparisons, right?
Yeah, and over the years, I remember, because now performance is, like you mentioned, Apple is displaying it everywhere, but a lot of people saying, yeah, performance is great, useful, but it's expensive. So there's always people say, do I really need to go through the benchmarking checkbox, or can we skip it? So what's your opinion on that?
It's a balance, right? Let's say it's really the balance. You should calculate the cost. And that's why there are different benchmarking categories. So you can choose from, like, maybe the cheapest one, maybe just production benchmarking, just measure how your production, how much it costs and how much latency you have. And if your users are really, kind of like sad and they go to competitor, that's your time to benchmark, right? Perhaps, and most likely you are wasting a lot of very easy to optimize fat, right? So my suggestion is to measure, have data-driven kind of decision-making, but also don't underestimate how much you can optimize your code, right? Don't go straight to configuration and, we can just scale, we can just go add more replicas. And sometimes it's just 2 lines of code that makes no sense. Maybe debug log line that parses or like formats some strings and for no reason, because you have debug logging actually disabled. So there are so much waste you can easily taken, right? To some point, at some point, the software is super hard to optimize to some level, but I'm sure you are not there yet, right? Like it's a lot of things you can do simply.
Yeah, and I think also sometimes the question is more about, maybe it's expensive, but maybe I'm avoiding a big disaster in production, and that will be probably more expensive than the test that I was planning to run, to be honest. All right, so Angelika, Tamimi, do you have any questions for Bartek?
No, that was a great talk overall, and great answer for the questions. I do not have any follow-up questions for what you just mentioned. Thank you again.
All right, so thank you all to be here. So I think we're almost above the time that I expected, to be honest. So I think we had a good conversation. So thanks for the three to prepare those talks, because it usually takes time to prepare the presentations and to stay here during an hour and so. So thanks for your time. Thanks for preparing things, and I will hope to see you soon in another Observable Lightning Talks, guys. Thanks.
Thank you so much, Henrik.
Perfect.
Thank you.
Thank you. Have a good night, everyone. Bye now.
Bye, everybody.
All right, so another Observable Lightning Talks. Thanks for watching this live stream. Again, this live stream will be available in a few minutes, in a few seconds in YouTube. So if you don't have the time to watch the entire live stream, don't worry, it's there in YouTube. And if you have any questions, just drop a comment on the YouTube video. And the next Observable Lightning Talks will be scheduled for December. So if you want to present any surprising topic or anything related to observability in general, just reach me out, and I will be very happy to invite you to this next Observable Lightning Talks. So if you enjoyed today's content, this live stream, don't forget to so press the like button and subscribe. And thank you for spending this 1 hour with us, and see you soon for another Observable Lightning Talks.